Welcome to the next installment in a series of GIS tutorials geared towards local officials on how to use FEMA base level engineering datasets in GIS to support flood hazard mitigation decisions. This tutorial series was developed by the Water Institute of the Gulf in partnership with FEMA Region 6 through FEMA's Cooperating Technical Partners program. In today's tutorial, you will learn how to import and symbolize Ble data downloaded from the BFE Viewer application. Today's tutorial has three primary learning objectives. First, we'll identify important Ble data available for download. Then we'll go over the steps for importing vector and raster Ble data into a desktop GIS. Finally, we'll detail some methods for symbolizing vector and raster Ble data according to best practices. Using guidance from previous tutorials, download Ble data for the watershed containing your area of interest. Users can download the HEC-RAS models, water surface elevation grids, flood depth grids, or a vector data set containing a geodatabase of floodplain extents, model cross-sections, and streamlines. For this tutorial, you will need the 4 raster datasets as well as the vector spatial data. Let's do a quick review of the data contents. The HEC-RAS archive includes the hydraulic models for all streams studied in base level engineering assessment. Event depths and event elevations are downloaded as raster features in a zipped geodatabase. The 1% event depths archive details flood depth elevations for a 100-year flood event. The 0.2 event depths archive includes flood depth elevations for a 500-year flood event. The 1% event elevations archive contains top of water surface elevations for a 100-year flood event. The 0.2% event elevations archive includes top of water surface elevations for a 500-year flood event. The Vector Spatial Data Archive contains a zipped geodatabase with a collection of spatial data used or created during the Ble assessment. The Reports and Documents Archive includes the Ble report that details terrain, hydrology, and other modeling details. This tutorial assumes you're working in Esri ArcGIS Pro version 2.4.2 or later. The build used in this video is 2.8.3. First, create a new ArcGIS Pro project for Ble analysis and put it in its own self-named directory in the ArcGIS or Projects folder on your local drive. You can do this by ensuring the Create a New Folder for this project radio button is checked. Next, return to the folder where the zipped Ble data was downloaded to. We want to extract the zipped Ble data into the same directory as the ArcGIS project we just created. After extracting the Ble data, you should be able to see the contents of the uncompressed folders by refreshing the projects folder in the catalog pane or catalog window. Here we can see the gridded raster data for 1% and 0.2% events for flood depths and flood elevations in their respective geodatabases. Also visible are the vector data, packaged in a geodatabase as individual feature datasets. Add the flood depth and water surface elevation rasters to the map frame. The applicable raster names are listed on screen. The rasters can be added by right-clicking on the item in the catalog pane and selecting Add to Current Map, or by clicking the Add Data button on the map ribbon. Given that the files are located in different directories, they will need to be added one at a time. From the vector data folder, add the following feature classes: SHUC area from the base layers feature dataset, detailed study areas, flood hazard areas, 10% floodplain, water area and water line from the eBFE layers feature dataset, as well as the census block area from the mitigation layers feature dataset. Vector features can be added by holding the Shift key, selecting each item in the catalog pane, right-clicking and selecting Add to Current Map, or by clicking the Add Data button on the map ribbon. Our first symbology focus will be on the Ble Depth Grids. We will symbolize our depth grids in two ways: as a stretched continuous surface and as classified based on the class breaks presented in the BFE Viewer application. The default symbology is stretch, with a black and white color scheme and a 0.5% clip stretch type. A personal preference is to symbolize depths on a blue to red full bright spectrum color ramp. It is also useful to unify both the 1% and 0.2% depth grids on a common statistical frame. You can do this by adjusting both datasets' minimum and maximum to reflect a common minimum value and a common maximum. First, identify the range of both depth grids. In this example, the 100-year surface has a maximum of 26.307, and the 500-year surface has a maximum of 28.4147. Both datasets have a minimum near zero. We will target 0 for a universal minimum and 28.5 for the universal maximum. Next, change the stretch type on the 100-year surface to minimum maximum. In the Statistics dropdown, select the Custom option and adjust the minimum value to 0 and the maximum value to 28.5. Adjust the lower and upper labels accordingly. Next, we'll apply the modified stretch symbology to the 500-year depth grid. Do this by highlighting the 500-year depth grid in the table of contents. Then click the drop-down to the top right of the Symbology pane and select Import from Layer option. In the Geoprocessing pane that appears, select the 100-year depth surface as the Symbology layer. The 500-year depth surface should automatically populate as the input layer. Leave Update Symbology Ranges by Data as Maintain Ranges and run the tool. The water depth grids can also be symbolized in a classified way, similar to how they appear on the BFE viewer. A classified symbology bins values based on computed breaks or user input. We will attempt to recreate the BFE viewer symbology using the 100-year and 500-year depth grids. Select the 100-year and 500-year depth grids in the table of contents. Right-click, select Copy, then Paste. Highlight the 100-year depth grid copy and change the primary symbology in the Symbology pane to Classify. The Classify option defaults to a natural breaks classification method with 5 total classifications. Change the number of classifications to 6 and change the method to manual interval. Now adjust the color ramp to one that mirrors the BFE viewer. In the upper value column under Classes, change the first 5 values to 1 foot increments ranging from less than or equal to 1 foot to less than or equal to 5 feet. Do not modify the last value from the maximum. Adjust the labels by decreasing the number of significant figures to 1. Modify the label columns to align with the BFE viewer symbology as shown in the table on this slide. Using the procedure detailed earlier, apply the symbology of the classified 100-year depth grid to the copy of the 500-year depth grid. Leave Update Symbology Ranges by Data as Maintain Ranges. Finally, apply your preferred terrain or bathymetry color ramp to the 100-year and 500-year water surface elevations. You can use the process documented previously if you want both water surface elevation rasters on the same scale. First, adjust the stretch type to minimum maximum, then change the statistics to custom, and finally, adjust the minimum maximum values to a common range. Vector data can be symbolized based on user preference. Experience has shown that the following symbology types are preferred. Symbolize the Huck area polygon as single symbol with a white outline and no fill. Symbolize the detailed study area as single symbol with black outline and no fill. Symbolize the flood hazard area polygons as unique values with flood zone as field 1 and zone subtype as field 2. The Zone A class is best symbolized using no outline and an orange fill. The Zone X class is best symbolized using no outline and a light blue fill. Symbolize the 10% floodplain polygon as single symbol with no outline and a yellow crosshatch fill. Symbolize water area and water line as no outline with a navy field. Census block area polygons have no specific symbology preferences. Today's tutorial covered three primary topics. We identified important downloadable Ble data. We documented the steps for importing vector and raster Ble data into a desktop GIS. And we covered some methods for symbolizing vector and raster Ble data according to best practices. Thanks for tuning in.